Okay, guys, I think we can start today's session. So, last session we have been discussing about the ROS to perception, and we have seen interesting stuff like the bridging between OpenCV and ROS image messages, and vice versa. And also, we have seen how to bridge the ROS to PCL, like ROS to point cloud to the PCL object, and also PCL object to ROS to point cloud messages. Okay, and we have also seen two framework like ROS to object detection using YOLO, which is already there. We can simply create it using a Python interface. I already shared that. And also for 3D object detection, for example, if you are working with some self-driving car stuff, if you want to detect the object and with a bounding box, 3D bounding box, I have shared the YOLO 3D, which is where we can work with ROS 2. One topic that I left was because of time constraint. I didn't explain about Open 3D. I actually mentioned about Open 3D what it is, but I didn't talk much about it. So I just want to give small idea about it. It's again, one second, one second.
Hello, sir.
Yes, yes, tell me.
How are you, sir? Is everything is fine?
Yeah, I'm good. I'm good.
Uh,
Yes.
if you have any good project on 3D, Open 3D, or computer vision, or YOLO V3, it will be great, sir, if you make any good project from scratch to end.
Yeah, so regarding the, YOLO roast, I think I already shared some projects, but it just show the detection, but not the application using YOLO. Maybe I can share after this. Okay, let
Sure, sir. Thank
okay,
you.
okay, yeah, yes. So I can first start with the Open 3D. Yesterday I have given a small overview of the Open 3D. It is like a rival or a better version or better uh, tool compared to Point Cloud library. We have the Point Cloud library, right? Point Cloud library, which is actually somewhat old, okay, but it's still having enough APIs to do the job. Okay, if you are looking for a modern library, then Open3D is one of the existing library, and you can install it in Linux, Mac, and all, and you can work with Python as well, Python and C++. Okay, so this is the official website of Open3D. I'm not explaining the APIs of Open3D and all. What I am trying to show you is that how we can bridge a uh, Open3D and ROS2. So that is the main thing that we need to know, because Open3D will have some kind of data type in order to handle point cloud. Okay, and on ROS2 we have ROS2 point cloud messages. So we need some example to show how we can bridge these two. Okay, so there is some kind of converter that is available. I don't think there is some bridge existing, but you can do it manually. Okay, so this example I found from the GitHub, which seems like a good one to explain the interface. Okay, so I just copied this example. I think, yeah, yes, I think this is it. PCD subscriber node, right? Yeah, exactly. Okay, so this example slightly bigger one, but I can explain what it is happening, what is happening. Yeah, so this is a code. You can also get the code from the link that I have shared. So basically this is a subscriber. Okay, this is a subscriber for point cloud, ROS to point cloud messages. Okay, and what is happening is that after subscribing, uh, they are trying to convert the point cloud into the Open 3D equivalent. Okay, Open 3D equivalent, and then they are visualizing it. Okay, so that is what they are basically doing. Okay, so you can see here there is a function for reading the points, then get extract. But just understand, this is like kind of an example which is connecting ROS to an Open 3D. So I'm not sure where it is using. I just found the example. So like you can find here. This is for subscribing to a point cloud. You can change the name. Currently I changed the name of the topic to PCD, and then whenever a point cloud message comes, it will be calling the callback, which is here. Okay, and inside the callback, this is the point cloud message. Okay, and then it is actually converting the PCD into NumPy array. Okay, and then that is actually using for converting into the Open 3D point cloud object type. Okay, so these are the lines of code which is doing the visualization and the conversion into Open 3D equivalent. So you can see the module that we are using for importing Open 3Ds like Open 3D. Okay, which we can install simply using apt. Okay, that I can show you, or you can install using pip. So if you simply search in Synaptic Package Manager, and then if you simply search for Open 3D, you can find it, the Python module. I already installed it. Okay, you can see here library for 3D data processing. Okay, and the Python binding. So this is the thing, and also I think there is a package. Okay, provide conversion function to and from Open 3D data type. So that is also there, but in this example they have implemented everything from scratch. That is what my understanding. So they have implemented a function to convert the point cloud message, which is sensor messages point cloud 2 into a NumPy array. But it seems like there is some bridge or converter available, like the PCL library. Yesterday you have seen the PCL thing, right? The PCL library, we can convert the ROS message to PCL and vice versa. Okay, maybe I can show you yesterday's example with the PCL. Just we have the PCL example, and here is the example. So I just mentioned that there is a package called PCL conversion. Inside that there is a list of API available. So this will be converting ROS to point cloud to PCL point cloud. This is converting PCL message to ROS 2. So these are the basic conversion function that we require. Similar to that, O3D also having that, so which is actually available here, Open 3D conversion. I didn't check this actually, but there is a functionality available, so I can install it. So like we do for the PCL library, we can convert into the Open 3D data type. Okay, so maybe I can check. Let me check for the package. Oh, sorry. Open 3D. Yeah. I think it's in the ROS perception stack. I can share it. And also there are some examples available. let me take one. Okay, so there is a publish. You can see the implementation using the Open3D conversion. Yes, I'm new to this. I was actually using that example to explain. But let me see how is it how they are doing. It will be almost similar to the point cloud library that is doing. So you can see here, this is what this example, I think you can check. So basically this code that you are seeing is a subscriber code. Okay, you can easily understand that there is a class, and inside that there is a subscriber for point cloud, and if there is any point cloud comes, it will be calling the callback, which is here. And then the data type that we are using for, in the Open3D is Open3D geometry point cloud. Okay, and we created an object called PCD, and this is the conversion function. So you can easily understand, like Open3D conversion, ROS to Open3D. So this cloud data, which is ROS message, converting to Open3D equivalent. Okay, I'm not expert in the Open3D APIs, but what it does is that it is doing the job, like it is converting the ROS to message to Open3D equivalent. Then we can use the Open3D APIs to process the point cloud, and then using the Open3D conversion thing, which is available in the publisher. Maybe you can see here Open3D to ROS. Okay, so this is a publisher for Open3D. Mostly I will actually check if there is any examples available. They have installed the examples or something. So in order to check that, you can simply check the properties and check for the installed file. So if they put any examples, we can able to see, but unfortunately they didn't mention. So maybe what I can do is I can build it. Okay, let me see whether that works or not. It's in the Humble branch. Okay, Open3D. Oh, okay, got it. So it seems like Humble branch, there are still, I mean, bugs maybe. So or they didn't port the package actually, so we can't able to build it. But basically, if you check the main branch and the example, this package didn't port to Humble it, so that's why we are not seeing it. So basically this is the example that you can take for publishing and subscribing a point cloud using Open3D. It's very easy. The main similarity between point cloud library and Open3D is this API that you can see here. It is Open3D conversion, Open3D to ROS, and in PCL, if you check, it is PCL conversion from PCL and to PCL. So if you compare and learn, it will be very easy to understand. Okay, so I'm just sharing the repository and this package so you can try it out. I actually ran some examples, which is this a Python example without using the PCL conversion API. So what I did was I was just publishing some point cloud. So I tried first with the Velodyne. So you have heard about the Velodyne LiDAR, right? But that is not working with the example. That may be because of the implementation. So I can show you what I did. I just started the Velodyne simulator. Okay, description. So the Velodyne, in order to install the Velodyne, you can still use the Synaptic Package Manager. There are packages available in Synaptic. You can install it and you can use the command called Velodyne description example.launch.py. So this is a simulation of Velodyne, which is having two models basically. And then I think we can also visualize it. Okay. So I actually given this point cloud to this, but it is not working that I'm expecting. It is throwing error, or it may be like there are much more point cloud. Yeah, it is taking a lot of time because there are many points coming, right? So that may be the reason. Um, yeah, and so in order to test it, I also tested with this PCL example, which is a PCL publisher, but it will be publishing only one point. Okay, only one PCL point. So I'm just um, I think not this. Let me check. Not this example. There's some example which is publishing rows to, yeah, I think this Python example, which is simply publishing the PCL, I mean the point cloud to particular topic called PCD. Okay. So yesterday we have seen that. Maybe I can simply run it and see rows to publish. Okay, so it is publishing a point cloud. We can check that. Rows to topic list, rows to topic echo. It is only having one point, I guess, so you can simply echo it. So and then you can run the open 3D. So currently the topic is publishing with the rows to point cloud. So the open 3D open 3D node, which is subscribing to that point cloud and visualizing it. So actually there is only one point, so I'm not sure that point is visualizing. I just tried, but in order to try it better, like I need a better point cloud, maybe from a real sense or something, but I don't have any simulator or something. Maybe at one point I can show you. Okay. So these are some of the examples that I have used. I will be putting that in the GitHub. So in order to explain the point Open 3D interface, I think this package is enough. Basically, it is having the publisher and subscriber. I think there is a question. Let me check. Yeah, actually, in order to visualize the PCL, yesterday we have done the visualization in ROS. Oh, just a second. But it's simply one point. You can see here. Maybe I can increase the size or something. It was actually showing yesterday, but I'm not sure. Maybe I just need to change the code again. Okay. Yeah, let me check it. It was single point that I can, yeah, now I can able to see. Just change it. Yeah, so this is a single point. So this point may be visualizing in the Open 3D visualizer. Okay. So yeah, so yesterday we have used this message to show some example. Yeah. So we can visualize it, and then the Open 3D subscriber may be visualizing the single point. Maybe that's why it is showing white. That is what my assumption. Maybe I will get a much better point cloud and I will show you maybe after maybe in the upcoming class. Okay. So just want to conclude the Open 3D stuff. Basically it's similar to the point cloud library, but it is having much better optimized functions or APIs for processing the point cloud. Okay, and also there are good documentation, community support, and it is having uh, uh, modern APIs, meaning it may be using latest C++ version, but the point cloud library, which is somewhat old, but it still do the job. Okay, so you can rely on the example, and you can use these PCL, Open 3D conversion function, which is what the important part. Okay, here there is a downsample example. Downsample means like filtering. For example, I'm giving a point cloud. It will be downsample the point cloud, and it will be publishing. So this example you can see similar to the PCL. We have the Open 3D object. Then using ROS to Open 3D function, it is converting into PCD, which is the Open 3D stuff. And then by calling a simple function, like after converting into Open 3D object, you can simply call the voxel downsample function. Okay, so what that mean was like this object itself having the function to do the downsampling. Okay, and then we have the filtered point cloud, and then using the same function Open 3D conversion, you are converting the filtered point cloud to ROS to PC2. We are simply converting to a ROS message, and then we are publishing it. Okay, I hope you got an idea. Let me know if you have any question in the thing, because we have seen OpenCV, PCL, all this stuff having the same way. Okay, only the APIs are different, so that's why I'm explaining like this. If you have any question, let me know. After that, we can jump into the micro ROS chapter and this one, because these two are connected. So let me see if I get time to discuss. Do you have any doubt about the Open 3D and ROS 2 integration? So this is the official website of Open 3D, and all the APIs are listed. I'm not explaining about the Open 3D because it will take a lot of time. It's very similar to the PCL library. We can do the the processing of point cloud very effectively compared to PCL library. Okay, so you can play it around, and yeah, you can share your work as well if you have done any. Okay, any question, guys? Any questions? Okay, so one of the advantage that I have seen with Open 3D is it is having a good Python wrapper. Even point cloud library is having one, but it's not by default, I guess. For Open 3D it was much better. Okay, so we are concluding the ROS 2 perception chapter. Because of the discussion that we have done with the ROS 1, the migration was pretty easy, because all the ROS 2 perception stack, ROS perception stack is migrated to ROS 2. Mostly the same APIs, but there are some APIs are still porting. Okay, so it is not that difficult to migrate. Okay, and the new stuff is Open 3D. Okay, so now we can jump into the embedded system ROS stuff. Okay, so that is what we are going to discuss. Currently I don't have the live demo to show the interface. Today I have ordered one from Robo. I'm not sure when will I get it. So in order to play with the micro ROS, the cheaper alternative is obviously the Raspberry Pi Pico. Okay, I can show you the. It's shipped only today, I guess. I ordered only today. Let me see. So I ordered a Raspberry Pi Pico W edition with Wi-Fi. Okay. One second, let me see if there is any issue with the network. Okay, so this is what I have ordered. Raspberry Pi Pico. Yeah, so there are two models that you can use to work with micro ROS. Micro ROS is simply in two words. I will say it's simply very similar to the ROS serial that we have worked with ROS one, but I mean some more advanced. Okay, some more advanced with more capabilities. If you remember the ROS serial, you may be remembering like we can program using Arduino, and then you can create a publisher, subscriber, all this stuff inside the Arduino. So from the Arduino we can publish some topic, and from the laptop we can subscribe to it, and also from the laptop we can publish and Arduino can subscribe. So a modern version. I mean, it's not the technology, underlying technology, everything is different, but I mean you can compare the ROS serial with the micro ROS. It's different, but the concept is the same. Okay, the main problem with the ROS, I mean, the main thing about the ROS serial is that it's actually a serial communication based protocol, so it will not take much CPU or RAM. Okay, but the micro ROS is not like that. Micro ROS is actually having I mean, I will say we can run a micro version of ROS 2 inside the microcontroller. Okay, so if you take the old Arduino Mega, Arduino Uno, it is not having that resources to run a micro ROS. Okay, but if you take the Raspberry Pi Pico, okay, it is a very cheap board. The Pico only costs around 399 or something Indian rupees. So you can see how cheap it is. And Pico W with Wi-Fi. I just ordered this because if I have any application to do, then I mean Wi-Fi based application, then I can use the Wi-Fi version. Only 200 rupees, yeah, difference. So this is the cheapest board that you can purchase to play with micro ROS. Okay, other than that there are a lot of boards available, but like for example, you will be seeing some examples of robot which is built using micro ROS, like Lino robot. Okay, which is a very popular project. They are using Teensy. Okay, Teensy. I had Teensy actually, 4.1 or something. I was searching for that. It was this very small board. I was actually planning to take the live session using Teensy, but unfortunately I couldn't get it. So today I just ordered it. I mean, not Teensy, this one. Okay, so we will be seeing the demo, and I will be showing some video, okay, in this class. So come back to the Raspberry Pi Pico, which is actually a very cost effective board, which is running on ARM Cortex M0, and which is having a frequency of 133 megahertz. Okay, which is very good. And also it is having 264 KB of SRAM and 2 MB flash. So for micro ROS, I think it's the minimum requirement is 10 kilobyte or something. I'm not sure. Um, and if you have this, then you can flash the micro ROS into the board. Okay. So if you want to try with micro ROS, first purchase some board like this. This very expensive thing to try it out. Okay, that is the first thing I just want to say. And in this chapter, what I am planning to do is that, like, I will be giving an intro about micro ROS. What is it? I will be comparing with ROS serial, and what are the good alternatives to create a robot, and programming using micro ROS, and controlling the motors, interfacing the sensors, and connecting the microcontrollers to some Raspberry Pi or computer and controlling the robot. Okay, so that is the main agenda of this chapter, but these two chapters are very connected. So in this chapter, what I am planning to discuss is that I'm planning to discuss the construction of a robot which is running on ROS 2. So I will be discussing the electronics part, and we will be seeing how to program it using the micro ROS, and then setting navigation stack, very basic details. Okay, navigation stack, AMCL, and I'm using the Lino robot 2 for discussing that. So which is very popular project. Okay, so coming back to the micro ROS, I'm first taking the website. You can simply search micro ROS. We will get the website. I'm just sharing it. You can check it. So when the micro ROS project started, I was very curious and also very interested, because I am coming from an electronics background. My bachelor's was in electronics and communication, and my master's was in robotics and automation. So one of the things that I like while I was doing bachelor's was embedded programming. So why I was fascinated for micro ROS, because I can work on the embedded stuff. I was working on the Arduino IDE, all this stuff, but it was not that exciting. But like running a ROS 2 on a microcontroller, it was actually exciting. Okay, so that's why I was keep on following this project, but I was not updating with the the things happening. I just see the news, but I didn't try. I was trying with the I think Teensy, but it was not successful. I was using Docker and all. Then I'm trying now. Okay, I'm just trying now. I know the concept, but I didn't get time actually. So this is what the micro ROS looks like. Okay, yeah, I can explain what is happening. Maybe using a PowerPoint slide Google. Okay, that will be better. Okay, so let me draw some blocks. Okay, so so if you build a robot and run with ROS, if it is ROS 1 or ROS 2, one of the way uh, that you can create the electronics or design the electronics is that um, there will be a computer. Say it's a Raspberry Pi. Okay, so it's a ROS based robot, right? So ROS is running on it. Okay, and so this is inside the robot. Okay, this is inside, and you can either control the motors using Raspberry Pi and also interface the sensors to Raspberry Pi. That is one option, but I will prefer uh, offload all these sensor interface, motor interface to a microcontroller, because microcontroller can work in real time, but Raspberry Pi don't, because Raspberry Pi runs on a Linux operating system, and we can make it as real time with a lot of effort that you can do. But I will prefer to offload all these sensor integrations to a microcontroller. Maybe like sensors, low level sensors like encoders, ultrasonic, all these simple sensors. But regarding the LiDAR, all this stuff, camera, a microcontroller can't able to handle, right? So I will be putting a microcontroller. Example, Arduino, Raspberry Pi, Pico. Okay, so these all are examples. And next comes to, if you know, we have motors and we have sensors like IMU, then encoders, Okay, so these are the main sensors that we are using for a wheel robot. So we can interface all these things to a microcontroller. Possible, right? We can generate the PWM signals and we can control it. Microcontrollers can easily generate the PWM. Then all the sensors can be controlled, and this microcontroller process all this stuff and then send back to the PC somehow. Okay, maybe it's not a single control. Um, yeah, maybe I can represent like this. So it's actually a bidirectional. Okay, and yeah, so now I have a laptop here. Laptop, and there can be a Wi-Fi here, and the laptop may be connected to the Wi-Fi. Similar to that, Raspberry Pi is also connected to the Wi-Fi. So there is a common network. So laptop can be like communicated to Raspberry Pi using SSH, and also like we can configure ROS network settings in order to I mean see the topics and all. Okay, so this is what one typical robot looks like. Okay, example, a wheel robot. This is one way of controlling. Okay, this is only one way. You can maybe directly connect all this stuff into Raspberry Pi. That is again another way. But mostly I am preferring this approach. Why? Because we can offload these sensors to microcontroller, and other stuff like LiDAR I can connect to Raspberry Pi. Okay, okay, makes sense, right? So uh, so before this micro ROS or Arduino or ROS serial, I can share one of my experience while I was working on my social robot in 2010 basically. So at that time, Arduino boards are just coming, but it's not that famous. So we have been using the AVR series board 80 mega 8. I'm not sure how many of you heard about this chip. This 80 mega 8 or 32, all these chips are using in Arduino. So we have been flashing this microcontroller using some serial programming circuit, and what I did was I actually used the Arduino IDE. At that time it was just coming, Arduino IDE, and generate the hex, and then using some flash utilities I just flashed into the microcontroller. Okay, but so microcontroller programming is done, but how to communicate to the microcontroller we can only do using serial communication, I2C SPI, right? So we have to create some kind of communication protocol, like if I'm sending a letter M, then two values of motor speed, then the motor will be rotating accordingly. So some kind of communication protocol we have to establish, then only we can communicate to this sensor and get the sensor data. Okay, so the problem is it will take a lot of time because there is no established communication protocol like ROS serial or micro ROS or at that time. So you got an understanding, right? Communicating with microcontroller and the computer, it was not that easy at that time. But when the ROS serial come, I was testing the ROS serial I think in 2013 or 2012 or something. I was very happy because it is too easy. Okay, it is too easy because you can create a publisher and publish the sensor data. You can create a subscriber in the Arduino, and when it subscribe the motor speed, you can simply drive the motors, something like that. It's very easy, right? So micro ROS is again the same thing like the ROS serial, but it's basically running like we can run micro ROS or a micro version of ROS 2 in a real-time OS or RTOS, or you can run with Arduino based board like Teensy or Arduino Duo in a like a bare metal fashion. I will explain that actually. So it will be better to start from the block diagram. I can explain it very easily. So here on the bottom you can see the microcontroller, right? So imagine we have the microcontroller called Raspberry Pi Pico. Okay, so in the Raspberry Pi Pico is capable to run a real-time OS. Okay, real-time OS are operating system which is more like Linux, but it's very optimized for low memory footprint. Low memory footprint means like a microcontroller is a I mean it's a system which is having a lot of capabilities, like it can produce PWM, it can talk serial communication, a lot of things are there, but when we take the spec of the microcontroller, it will not be that great compared to microprocessor. So in Raspberry Pi Pico, we have seen it's only having 122 megahertz, and the RAM is also not that great. So in that kind of computer or microcomputer, we need some kind of operating system, okay, which can run, and then we can run micro ROS on the top of it. Okay, so you can see Sapphire, FreeRTOS, NUTX, all these are um, real-time operating system. It is having I mean Linux footprint. Okay, so it's kind of complete operating system, but it's very basic. Okay, but it can run on the microcontroller, and on the top of this RTOS we can run ROS 2 or micro ROS. Okay, so I'm sure that you know the block diagram of ROS 2, right? It is having the main thing called DDS. Okay, so here in micro ROS also there is a DDS called micro XRC. It stands for like very small resource. Very small resource means it's only having it will be only using uh, small memory footprint. Okay, that is XRC. I think um, there is a concept they are showing in the examples, not example, in the tutorial. So this is the XRC DDS. Okay, so it stands for extremely resource constrained environment standard. So again, it's a DDS, but it can be used in microcontroller. Okay, it's maintained by Proxima company, and similar to that, similar to ROS 2, we have the DDS adapter, then RMW, which is interfacing DDS to the upper level, and on the top we have the programming language interface. Currently only C language is supported, and C++ in micro ROS is also coming. Okay, so what happening is that, like, you will get the RCL APIs. RCL means ROS API in C language. RCL CPP is ROS to APIs in CPP, and there is RCL Pi that you know. So for micro ROS, as of now, we have, I think, RCL. Okay, RCL, which is RCLC basically. Okay, RCLC. So you can write code in RCLC. Okay, but if you remember the ROS serial, it is different. It is having publisher, a subscriber, but it's not like the actual ROS node. Okay, there is similarity, but it's actually custom built. Okay, it's that ROS serial is a different implementation. Okay, but this is actually exactly similar, very same as the ROS 2. Okay, so this is a micro version of ROS 2, but it's having almost all the capabilities of ROS 2. Okay, there is a comparison that you can check that I will be sharing, that is in the website. It's actually very interesting. I will be coming to that. So this is the main um, block. Okay, on the microcontroller we are deploying micro ROS on the top of a ROS. Okay, and there is micro XRC, resource constrained DDS, and also on the top we have C APIs. Okay, on the other side, okay, we have micro ROS Arduino as well. So what is micro ROS Arduino does? Uh, it is called a bare metal implementation, meaning we can work on very low level uh, thing. So here, in order to work with Arduino, we don't need to work or install the what the RTOS, but instead of that, they are implemented kind of a library. So you can install the library in Arduino IDE, and you can write program on the Arduino IDE. So it will be working similar to the ROS serial. So in ROS serial, if you remember, you need a Arduino library. You have to include that, and then you can compile and flash the Arduino, right? Similar to that, we have micro ROS Arduino, and which is actually very interesting. If you check, this is the main repository, which will be useful to us because the micro serial Arduino will be supporting Teensy board, and also the I think it's also supporting like the Raspberry Pi Pico. I'm not sure. I need to check that. So this is one main repository which is replacing. There is no need of RTOS. On Arduino, we can simply use this micro ROS Arduino package, which is like, I mean, it's an Arduino library. So this is the structure. Like you can see the examples. There are micro ROS publisher. You can compare with the ROS serial. There are a lot of similarity. But if you check the code is not the wiring language that we are working with the Arduino. I mean, you can see the setup function, then loop function that you are working with Arduino, but inside that the APIs are mostly C. Okay, so that is what I mentioned, bare metal. So if you work with uh, AVR C++ or like embedded C, I mean, it is similar to that, but they are using both. You can see here we are using pin mode, which is a Arduino kind of function, but like there are more C APIs on micro ROS Arduino. Okay, so these are the two methods that you can work. There are some boards which runs RTOS, and you can set up the micro ROS on it, and there are micro ROS Arduino, which is a separate I can say it's a spin-off from the micro ROS main project. Okay, so the main project, if you check, you can see the GitHub is this. Okay, so this is the main repository for micro ROS. So the micro ROS, what they are doing is they are creating spin-off for different board. So here you can see micro ROS Raspberry Pi Pico SDK, then micro ROS Arduino, then micro ROS Sapphire, because micro ROS setup is basically some tools to I mean flash the firmware. Okay, that is mainly the thing, but you can see a list of repository, okay, which is supporting each board. There are community supported, and also there are officially supported board, okay, which is everything is actually in the website. I will be coming to that. And also you can see, so we have seen the main blog, and just look at the left side. So here this microcontroller, okay, this microcontroller is connected to a laptop. Okay, So on the left side you can see the computer. Okay, so in our case it is Raspberry Pi. Okay, so mostly the microcontrollers are connected to the computer using serial, I mean USB to serial interface. Okay, so it will be detecting as a serial port. Okay, that is how we are connecting Arduino and everything to the Raspberry Pi. Okay, so that is what's showing. Okay, and if you remember the ROS serial, uh, the ROS serial, yeah, after connecting the Arduino, we need to run a thing called ROS serial server or something. Okay, so which is actually doing the decoding and encoding messages from the Arduino. Similar to that, micro ROS is having a thing called ROS2 agent or micro ROS agent, which is doing the same stuff mostly. Like the messages are serialized and deserialized, and you can see the topics from the microcontroller in the PC and vice versa. Okay, so this is what micro ROS in a nutshell, and from the website you will get more information. I can quickly go through the website, which is very interesting. So we have seen this, and I'm going to the next page. They are talking about the officially supported hardware that I mentioned. So there is a board from Renesas, then Sapphire. I mean, you heard about the ROS, right? Then so these all are Raspberry Pico is also officially supported, which is a good thing. Okay, and OpenCR board, which is from the Turtleboard 3, or I mean from the company called Robotis. Then TNC is supported, STM, and also there are community supported board. Arduino Duo 0 is all community supported, but I think it will work. Okay. Then supported RTOS. I think from the block diagram itself we already seen FreeRTOS, Sapphire, Nutex. I didn't work with these RTOS before. And also the bare metal support. Bare metal support means we can work with Arduino IDE by taking the low level, I mean by accessing the low level of the microcontrollers. Okay, we can access the low level features, but in normal programming it was not it was not able to do. Then embed OS, which is for ARM based board. um, this, okay, they're talking about each build tools. We can focus on the micro ROS for Arduino. Then what? I'm simply going through on each page. Okay, so let it load. So what happening is that these communication, I mean the communication between Raspberry Pi and microcontroller can be done more efficiently and more professionally, I will say, using ROS serial or micro ROS. So in case of ROS 2, if you are working with ROS 2, then you have to use micro ROS. There is no ROS serial library in ROS 2, so we have to rely on micro ROS, which is much better than ROS serial. Okay, but the same concept. Okay, yes, and they are talking about the licensing. Licensing is mainly Apache license, and one is GPL. Okay, so that is the licensing of each component. You can use it for professional, I mean commercial application. So there is a comparison. So this is what you have to look. There is a nice comparison between ROS serial, and there is another project called Riot ROS 2. So if you simply search, you can find it's actually an old project which is not supporting now. Supporting means they are not maintaining now. And so if you already know ROS serial, you can simply compare how good is micro ROS. Okay, so ROS serial was basically like we yeah we basically build on Arduino library in micro ROS we can work on a real-time operating system. Okay, but in case of Arduino, we can write it on bare metal level as well. Okay, and both these communication, I'm just ignoring this riot ROS because it's not valid. So it's bridge means like you are connecting the controller to the PC. Okay, using a USB something, and the message format is first in ROS serial is ROS1, and in micro ROS is CDR. From the DDS, the serialization is in the CDR format. Okay, I mean CDR. Yeah. So like that, they are comparing the UART. I mean the communication through UART. I mean, even if you are using USB, the internal communication are happening in a USB to serial communication. Yes. So yeah. So if you compare, you can see a similarity. So that's why I am asking you to check. Okay, it's the same thing, uh, and also they are comparing with ROS 2 and micro ROS. Okay, like ROS 2 is like a full-fledged thing, but micro ROS is a micro version of that ROS 2, right? So what are the things available? Okay, and what are the things not? Okay, so main thing is in micro ROS we can program using RCLC, but in ROS 2 we can program using C++, Python, all this stuff. Okay, and another important stuff is that in ROS 2, based on your laptop configuration, you can subscribe to big messages like point cloud images and all, but there is a limitation obviously in micro ROS. And yeah, ROS 1, ROS 2 communication can happen, and ROS topic is available in micro ROS, services are available, actions are available, but parameters are not yet implemented, and the discovery nodes, all these things are available. You can do the inter-process communication in a shared memory architecture. Then launch systems are not available. So all these things, there is a good comparison they have done, so we will get a good idea. Okay, and the concept, I think we already yeah, we already discussed. Yeah, regarding the features, this is important. Like we can have nodes, publisher, subscriber, service, then graph, executor, lifecycle, parameters. So parameters are there, but I think there are some upgrade happening. Yeah. So these are the things that you need to understand, I guess. Okay, and they have the tutorials to work with different boards like micro ROS application in Linux. I think we can install micro ROS on Linux as well, and also to RTOS. Okay, and they are talking about like Sapphire emulator, TNC. So we are mainly focusing on the TNC with Arduino. That is a thing that is suitable for us. Okay, and they are talking about the tutorial like how to program a node, its APIs, all these things mentioning here. Yeah. So maybe it will be better to see a demo of micro ROS, I think. Let me see. I think there is a example here as well. There are a lot of examples in YouTube, by the way. So just to show how is it working, maybe I can check the videos from here as well. Let me see. Okay. Okay, maybe I can search for one video, so you will get an idea how the thing working. I'm taking from the YouTube only. I had some links actually, but let me check. So in the meantime, like, you can have a look on the website, and this is one thing that you can check. Okay, I'm planning to show this in the video so you will get an understanding. So our focus is into boards like Arduino like platforms like Arduino Duo, Teensy, and also cheaper platforms like Raspberry Pi Pico. Okay, so we will see how to flash the firmware, and also how to run the ROS to agent in the PC. It's very simple as compared to if you already know the ROS serial. It's very similar. So let me just take some videos in the meantime, so you can have a look onto this. One second, and let me take the video in the meantime. Okay. Yeah, I think there is a demo. Yeah, I think there are some demo here. Okay, you can see the demo section as well. So they have mentioned how ROS to interface. I have seen some demos as well in some conferences using Crazy File. Crazy File is a small drone which is very good. Okay, I really like that demo. Let me check if there is any video. Okay, so you can simply have a look onto the demo and all. So in the meantime, I will come up with the video to I have taken it, but yeah, I got one. I think this will be enough to explain what it is. One second. Okay guys, so you can have a look. I think yeah. I think this is fine, I guess. Okay, so you can see here from the PC, this terminal is running from the PC, and you can see the first command. I'm not sure you can able to see it or not. On the top, we are running the agent. Okay, agent, I hope you understand what is an agent from the block diagram. One second, where is the block diagram? Okay, yeah, so the agent is here on the PC. So we have to run a program. Agent means simply a program which is handling messages from the microcontroller and also sending the messages to the microcontroller. Okay, so this is the command which is showing running the micro ROS agent. Okay, and it is running, and so this is an ESP32 board. Okay, which is already flashed with a micro ROS code. Okay, it may be a publisher, subscriber, anything, and then this guy is going to connect the USB into the ESP. Okay, just connecting the board to the PC. Okay, so it's connecting, and then after connecting, immediately you can see it's detecting. Okay, this agent is constantly checking for devices in a particular port. Okay, so once it connected, it's immediately detected, and now you can list out the topics. So you can see there are two topics, that is publishing or subscribing from the micro ROS. You can see here on an OLED panel, you can see there is P switch and S LED. So mostly, like, if you are publishing a topic on S LED, it will be blinking. Maybe switch will be a publisher. I mean, when you press a switch, it will be giving the data. So basically it's a publisher and subscriber. So we can see what is happening. So in order to run the agent, no, you just need an Ubuntu and the ROS2 environment. Okay, or if you don't want to run on like if you are not working with a ROS2 environment, you can run it on Docker as well. Okay, so I will be showing that command anyway. So but after seeing this video, you will get an idea. So here what we are doing is we are just publishing a message to micro-ROS SLED. Okay, data 1. So what is happening, or currently it's 1, I guess. So putting 0, nothing is happening. Let's see. Okay, it's actually toggled. I'm not sure what happened. Yeah, writing 0. Okay, it is taking some time, by the way. I'm not sure there is a delay or something, but putting 0, it will be turning off. And switch will be like if you press the switch, it will be giving one or something. Yeah, so if you are releasing it, it comes to 0. So basically like publisher subscriber, and you can see the value in the OLED as well. That is good. Okay, so if you publish 1 in the LED, okay, you can see on the LED also it is updating. Okay, LED means OLED screen. Okay, yes, so this is what micro ROS is. Like we are connecting the board, we are starting the agent, then upon connecting the device, you can able to see the topics, and then you can communicate. So I will say almost similar to the ROS serial. Okay, and yeah, so I think I forgot something. Yeah, so this is one, and then we can simply see this thing, the commands basically. So in order to run the agent, okay, that is one thing that we have to start from the computer. You can either set that agent in a Docker means like you are not installing on your PC main operating system, but instead you are using a Docker to isolate all this setup. So you can start a Docker which is having the ROS2 environment and all, and then you can run the agent in the Docker. Okay, that is one way. So here they are showing the command to install this agent, okay, using a shell script, and this is the command that we are using to run the agent. Basically the package name is micro ROS agent, and the node is micro ROS agent again. I think these are the arguments, it seems. Okay, the device the serial device name is TTY-ACM0. So once we entered, it will be showing like whether the serial port is found or not. Okay, if it is not found, it will be waiting. Okay, it will be waiting. That is a good thing. In ROS serial also there was some problem with the permission and all, but this is better, I will say. Micro ROS is much better, I guess. So once we done this, it will be, I mean, that's it. You just connect the device and then you are good to go. Okay, so in order to work with Teensy is like a board which is having a good spec, and you can program the board using Arduino IDE. So it's called Teensy Dino. Okay, and what you can do is you can download the micro ROS Arduino library. Okay, put it in the library path. You can see the Arduino library path, and then you will get the examples. Okay, the micro ROS Arduino publisher, you can simply compile it and then burn it into the Teensy, then after burning, connect the Teensy into the computer, run the agent. Now you can see once you start this agent, it's complaining about like serial not found or something, but when you connect it, you can see it is detected all this stuff. and then if you do the ROS topic list from your PC, you can able to see the topics. So it's very simple. If you know the ROS serial Arduino, I mean a ROS serial Arduino, yeah, it will be easier for you. But from my experience, the difficulty is on like setting the things in Docker, and also the permission issue, all this stuff. But that depends. Like um, when I tried from my side, I think it's 1 year ago or something, 1 or 2 years ago, I was getting some issues with the Docker and all. But you can try. When I get the Raspberry Pi Pico, I will also show some demos. So this is for the Twin thing. And if you want to work with micro ROS Pico, yeah, micro ROS Raspberry Pi Pico SDK. This is the I think, yeah, this is the repo for that. So in order to work with Pico, there is an SDK actually. Okay, so we have to set that SDK. Then there are some examples to flash it, then starting the agent, all this stuff. I think I have tried with Pico, I guess, last time, but it was not, I could able to flash, but it was not working fine. But I will try it again. They are also showing the agent using Docker. Yeah, so yes, so basically in order to flash it in the Pico, just install the SDK, Pico SDK, and then build it, and then burn it. I think this is the command for flashing the code. The firmware is with extension called UF2 into the Pico. Like when you plug the Pico, no, it will be detecting as a flash drive. You can see the flash drive which is having 256 MB or something, 2 MB or something. So you can simply copy this UF2 file into the Pico. That is actually very easy to work with. Okay. Yeah, and there are some examples. Pico micro ROS example. There is a publisher. Yeah, you can see here Pico micro ROS example. So this is one example using Pico. It's not that easy compared to Arduino, but it still work. Okay, it's a publisher, I guess. Yeah. Okay. Okay, so that is micro ROS. I think you got an idea about the micro ROS, and I just want 10 more minutes to explain or to start with the an application in micro ROS, which is a robot that I'm talking about. So these two things are connected because we are planning to implement the microcontroller interfacing using micro ROS. Okay, so we are using the project called LinoBot or LinoRobot for the learning, for the reference. I'm sharing it. So LinoRobot it's actually a hobby project. I know the author personally. So he created two main projects. Okay, his handle is Gradually. I think you may also heard about him. So he is having two main projects. One is LinoRobot, LinoRobot 1 and 2. One is for ROS 1 and 2 is for ROS 2. And you may heard about the CHAMP, which is the MIT Cheetah implementation. Okay, so these are the main two projects that he's doing. So LinoRobot will be a reference for you to build a ROS 2 robot. So I just want to show you the hardware part first. Okay, so we already discussed about the micro ROS, all this stuff. So just want to show you that, and I will conclude. Okay. Okay, so here this is the entire um, robot software architecture, I will say. Okay, it's very simple. If you observe, uh, on the bottom side you can see micro ROS library on robot microcontroller. Okay, so on microcontroller of this robot, which is running on micro ROS, and it is having some library like kinematics, PID, motor driver, motor, encoder driver, encoders, IMU driver, and IMU. Okay, these are some library. And so the microcontroller is using micro ROS and is running some nodes. Okay, and in the other hand, on the robot computer there is micro ROS agent. Okay, you know what is the agent doing, right? It is communicating to the microcontroller and then publishing, subscribing the topic. So from the agent, we will get the IMU data from the microcontroller, then ODOM data, and also you can publish the command velocity to the microcontroller. Okay, so if you publish the command velocity to the microcontroller, it will be moving the motors. Okay, and then ODOM and IMU we got, and then we can fuse it using EKF, and then we can generate the ODOM and TF and then putting into the navigation stack. Okay, so this is what basically it does, and this is one overview of the hardware, which is good to see actually. So you will get to know how, I mean, you may already seen this kind of schematic, but just to see what is happening in a robot hardware. So basically, in order to control the motors, we have a motor driver. Okay, motor drivers are circuit which can able to uh, adjust the speed of the motors, okay, by adjusting the voltage. So here on the left side we have TNC, on the center we have the motor driver, and on the right side we have the battery. So the purpose of the motor driver is to adjust the speed, and the TNC board will be giving the PWM to adjust the speed. Okay, PWM or some kind of signals to, mainly PWM, to adjust the speed. Okay, so TNC will be giving the PWM to the motor driver, so we can adjust the speed of the motor. So that is a basic motor interfacing. Okay, and he is showing multiple robot drivers basically. So this is L298, I think. So there are multiple robot motor drivers we can use, and also he's also showing the interfacing of a IMU. So IMU is important because in order to correct the orientation, you better will be putting an IMU. So he's putting an IMU and interface to TNC. So this is the final diagram of the robot. So it's interesting to see it. So from the microcontroller, you can see it is interfacing IMU, then motor drivers are interfaced and motors are interfaced, and we have encoders. All these encoders are connected to the interrupt pin. Okay, so whenever the encoder value change, the interrupt will be ticking, and then it will be counting. Okay, and then microcontroller and the robot computer is connected using USB, and the protocol is micro ROS. The microcontroller is running on a micro ROS code, and robot computer, it can be Raspberry Pi, Jetson Nano, anything. It is connected to a depth sensor and a laser scanner. Okay, so this is what a robot basically having, and the voltage levels are also like mentioned here. Okay, so it will be better to have a look on to this. Okay, so I'm concluding the session now. Next class we can simply go through the code of Linoboard. It's very similar to the ROS one, I'm saying, because like from this diagram itself you can understand what is happening. So we can go through the micro ROS code, we can go through the navigation, then drivers, all this stuff. Okay, and then we can switch to yeah, after discussing the project and all, we can switch to some other chapter, maybe, yeah, maybe some interesting stuff. Okay. Okay, so now it's a time for question. So let me know if you have any question in the micro ROS or Lino Robot 2 hardware. Let me know. So yeah, I can answer. Any questions, guys? Is it clear, or do you have any questions?
Sir, excuse me.
Yeah. I think your voice is very high. Yeah, you can talk with distance. Yeah. Tell me.
Sure. Sir, why will not that same rose code on the micro rose, controller? Can we write the same rose to code?
Actually, no. Basically, ROS 2 code means ROS 2 node can be written in C, C++, Python, and some other language. So in micro ROS, they are using C API, RCLC. So if you are thinking like that, then the RCLC APIs are mostly same in micro ROS and ROS 2, but you can't run a RCL CPP code in micro ROS because it's not yet implemented. That is what my understanding. You can't run a
Okay.
You can't run a ROS RCL CPP code or RCL Python code. You can only run RCL C. Okay, RCL C code. That is mostly compatible. But again, you have to do some kind of adjustment in it. But mostly the APIs will be same. Yeah.
Sir, the crazy fly you
Yeah.
mentioned
Yeah.
in
Yeah.
yeah, there RCLPY and RCLCC is working.
In Crazy Pie?
Yeah, in crazy fly.
Yeah, sorry, Crazy Fly. I think like on the microcontroller level that I'm talking, on the microcontroller, mostly it is RCLC only. That's what they are saying. You can check it. Maybe I can also check. From my understanding, like on the microcontroller, because micro ROS is mainly on the microcontroller level, right? So on the microcontroller level, they are using RCLC, but it can be connected to the PC, and then we can use maybe some Python code or something to visualize. But on the microcontroller, it's still C, I guess. I can yeah,
Okay, okay,
because we
okay.
are talking about the microcontroller level.
Sure.
Yeah.
Actually, I have working on crazy fly, so I will mostly what we'll do. I will write the code on laptop and then transfer through the radio to the controller.
Yeah. So, I think so how you are creating the code? Like in which are you writing in C, C++, or Python?
Yeah, C++ and Python both.
Okay, then you are copying to the crazy fly.
Crazy fly, and it works. Yeah.
But that I need to check, because if you want to flash the firmware, I think maybe what I am thinking is you can maybe control the crazy fly maybe using Python and CPP. That I'm not sure, but you can write the micro ROS APIs only in C. So did you tried micro ROS sorry, the ROS 2 APIs in Python and C++ and move to crazy fly? Did you do that?
Yeah, I did. Yes, I did.
Okay. That I need to I
Yeah.
need to check it again, because from the documentation they are saying only about the C. I didn't tried it, and but I have seen it in a conference actually. But it is actually showing some visualization in RVs, and if you are just moving the crazy fly, it is showing that visualization in RVs. But let me cross check whether the Python code is going to build, because here also you can see it's basically building the C code from my understanding. But I will be cross checking that. Okay,
Sure.
okay.
Maybe next week, maybe we'll discuss more
Yeah,
about
yeah,
it.
yeah. I have a doubt because
Yeah.
the micro rows will be only taking C, but not taking the RCL Pi and RCL CPP. So that is from the official documentation actually. So how the
Mhm.
Crazy Fly is able to work on the Python and the CPP? So that I need to check. Okay,
Sure, sir.
okay.
Thank you. Thank
Yeah,
you, sir.
yeah. Any more questions?
No, sir.
Okay,
Thank you.
okay, okay. Okay then. So I think we can conclude for today. So thanks for attending, guys. See you on next
Thank you,
class.
sir.
Bye.